This last video, 7.3, is brought to you by Lego Droid from Star Wars. Not sure who this one is. I'm sure it's got a name. Anyways, we're going to look at some lesser used ones, at least lesser ones that I used in my math career. These are the product to sum and sum to product identities. So we are just going to use this product to sum identity, just practice how it works to rewrite this mess in terms of a product. So that means, I pointed to the wrong one, we're going to look at something of this nature and rewrite it like this. So notice our identity that says take whatever is in whatever we're evaluating sine of, and that's your x in the first one, and the other thing is your y. So it's 7 beta for this one minus 4 beta in the second one. So we're going to use this thing. So sine of 7 beta minus sine of 4 beta. By the way, if you don't like the variables given to you, just change them. Like if they're annoying to write, like I kind of feel like beta is annoying to write. I could have just changed it to x and y, but that might have been confusing because the identity uses it. I don't know. All right, so we're just going to rewrite this as 2 times cosine of 7 beta plus 4 beta, all of that divided by 2. We're evaluating cosine of that. That's just directly applying this, times sine of, and now it's the difference of these two, 7 beta minus 4 beta divided by 2. I'm taking sine of all that. Okay, so our job then is to just do the algebra within those and see if anything pops out. So this is going to be 7 plus 4 is 11 beta divided by 2, and then 7 minus 4 is 3 beta divided by 2. And I think we can be happy that that's it. We've turned it into a product, and there it is. So now we're going to go the other direction. We're going to take a product and turn it into a sum. So I need to find in my identities which of these identities has cosine times cosine, and it's this one. Now notice there's this 7 out front. So we're just going to leave that 7 out there. Oh boy, this is theta. I don't like theta either. Cosine of 7 theta. Theta. Okay, so my identity says rewrite this as 1/2 times this whole mess. Well, because there's this 7 there, we can just write this as 7/2 times this mess of stuff. So it's cosine of the difference of the angles, with the first angle coming first, the second angle coming second. So that's 5 theta minus 7 theta. And then that's going to be plus cosine of the sum of those two, cosine of 5 theta plus 7 theta. Okay, again, let's do the arithmetic within this and then see if we can do anything from there. So this becomes cosine of negative 2 theta plus cosine of 12 theta. Now, at this point, there's bunches of things we could start thinking about doing. For example, what is cosine of a negative angle equal to? And I'll be honest, I'm going to have to look it up because I'm not confident in my memory. I believe it's just cosine of that same angle. I should go through thinking about how to prove that to myself, but I'm just getting super lazy. I'm going to look through all of my reference sheets and find it. Yeah, here it is. So cosine of a negative angle just equals cosine of that angle. So within the parentheses, we could just rewrite this as cosine of 2 theta, because who cares about that negative angle, plus, and just for fun, I'm going to rewrite this as cosine of 2 times 6 theta. Again, I don't know if this is useful. I'm just playing here to see where it goes. Now, I know that cosine of a double angle can be written in 3 different ways. We did that back in 7.3. It was this page. So I could rewrite it as cosine squared minus sine squared. I could do it as 1 minus 2 sine squared, or I could do it as 2 cosine squared minus 1. So let's just pick one of those. Let's do it all as cosines. Again, I don't know that this is going to get anywhere. I might decide that this is my final answer and just leave it at that, or this might turn into something interesting. So I'm going to rewrite this first one as just 2 times cosine squared theta minus 1. That's exactly what this is. And then this one is, so we'll do plus 2 times cosine. Now notice this entire thing is the new angle, right? So it's a 2 times this is my x. So it's going to be cosine squared times 6 theta minus 1. And you know, as I'm seeing this, I don't think this is going to get us anywhere. So I think I'm just going to call it here. Well, I mean, no, let me do this. I don't need these parentheses anymore. And we've got a negative, 2 negative things here. So I guess I'll start doing some algebra. So we'll get 2 cosine squared theta, and then plus 2 cosine squared of 6 theta, and then minus 2. So I could factor out this 2, and then that factored out 2 would cancel with this 2 in front, so I could have 7 times, and I'll rewrite this one first. Cosine squared of 6 theta plus cosine squared theta minus 1. Boy, I don't know that any of this is useful. But there you can see the types of things you can do to mess with these trig expressions. In this case, this isn't an identity or anything. And we could try to go further with these things, but this one gets pretty wild. We'd have to rewrite this as it just gets crazy, and I think it's just going to get far more complicated than what we want. All right. Now we're going to do an identity that uses these identities. So our goal is to rewrite this as that, or that as this. And I've tried this one in past times, trying to not use any of these sum or product identities, and it just gets kind of insane. So I'm going to take this tangent of x plus y, I'm going to rewrite it in terms of sines and cosines, and then I'm going to use one of these two formulas to get there. So just rewriting tangent, this becomes sine of x plus y over 2 divided by cosine of x plus y over 2. Right, that's just our definition. I'll write that here in case you're forgetting. Tangent of x equals sine x over cosine x, one of our basic identities. Now, our goal is to make this entire thing equal to sine x plus sine y divided by cosine x plus cosine y. Okay, so it looks like we're going to want to apply these some identities somewhere in here to end up getting this. Well, actually, now that I'm looking at this, I'm going to rewrite these in terms of these sum angles, and maybe I'll end up with this. Okay, my apologies. So I'm going to rewrite this sine x plus sine y. It's just exactly this, right? So it's going to become 2 sine of x plus y divided by 2. Oh, look, there's that piece. And then this is cosine of x minus y divided by 2. And then this is all going to be divided by, I'm going to rewrite this cosine x plus cosine y, which is this thing. So that's 2 times cosine of x plus y divided by 2 times cosine of x minus y divided by 2. And I'm going to say a bad word. Sorry, you couldn't see what I was writing. So I rewrote this. It's just directly applying the identity. So now it looks easy. That's a bad word for a teacher to say. Nothing in math is easy. So these two factors are the same. They divide out to 1. These two factors are the same. They also divide to 1. And we're left with this beautiful sine of x plus y over 2 divided by this cosine of x plus y over 2. And that's exactly what I started, well, what I rewrote this first thing as. that sine, just rewriting what tangent was. So maybe it wasn't terrible that I did that first. It's just that I wasn't using an identity to mess with this thing any further.